Now, next question is about describe the Kennedy's theory for the design of irrigation canal in alluvial soils. What are the limitations of Kennedy's theory? This question asked in 2022 for 7 marks. The design procedure will depend upon the bed slope is given or the width by depth ratio is given. First is the design procedure when slope is given. The given data will be discharge N, M and S. Step 1. Assume a trial value of the depth d in meters. Step 2 is calculate the velocity v from equation v is equal to 0.55 m into d raised to 0.64. Third step is find out the cross-section areas A is obtained from q is equal to a into v, a is equal to q by v. Step 4 is assuming the side slope of the canal 0.5 is to 1, horizontal is to vertical. The bed slope B is determined from the relation A is equal to BD plus D square by 2. Step 5 is the computer parameter P and hydraulic mean radius R from the following relation P is equal to B plus under root 5D, where R is equal to A by P. Area is a BD plus D square by 2 and perimeter is a B plus under root 5D. Next step 6 is calculate the actual mean velocity of the flow V from a Cutter's equation. If the value of V obtained from Cutter's equation is nearly the same as possible in step 2, the assumed depth is correct. If not, assume another trial values for D and repeat the calculation till the two values of velocity determined in step 6 and step 2 are nearly the same. Now, second is procedure when design procedure when B by D ratio is given. Given data will be Q and M and B by D ratio. First, calculate the A area in terms of D as indicated below. BD by is equal to some values as given X. So B is equal to D into X. Since A is equal to BD plus D square by 2, we can put the value of B here. So we can get simplified by this. By simplifying, we get the area is equal to D square by X plus 0.5. Second step, write the continuity equation. We all know the continuity equation for this side is Q is equal to A into V. Thus, Q is equal to D square. We put the value of area D square X plus 0.5 into equation for velocity is a 0.5 0.555 m into d raised to 0.64. We can find from here, we can find d value of dq because we have the value of q already given here in numerical or design procedure. Knowing d, calculate b and r from the following relations. B is equal to x into d. We have value of d we can put here and we can find out the value for b. R is equal to bd plus d square by 2 or b plus under root 5 into d, which is a by b. Calculate the velocity v from Kennedy's equation. So v is equal to 0.55 m into d raised to 164. Step 5 is the knowing v, r and n. Determine the bed slope s from Cutter's equation by trial and error. Neglect 0.00155 under root s in the Cutter's formula in the first trial. So these are the design procedure for when b by d ratio is given. Next is a drawbacks or limitation in Kennedy's theory. The various drawbacks in Kennedy's theory. First is that Kennedy did not consider the importance of B by D ratio in the theory. Cutter's equation is used for determining the mean velocity of the flow and hence the limitation of Cutter's equation are incorporated in Kennedy's theory. Kennedy does not give any equation for bed slopes. By varying S slopes, a number of design can be obtained. Kennedy did not mention which is most efficient design. Silk grade and silk charges were not defined. Fifth, the theory is aimed to design only the average regime channel. The value of M is decided arbitrary since there is no method given for determining its value. Seventh is the design of the channel by Kennedy's theory requires a tedious trials and error procedure. Thank you. So this is for limitations of Kennedy's theory.